Today we will discuss various temporal models which have been proposed over a period of time. As we have already discussed about temporal databases and the important concepts which are related to design and develop temporal database applications. Um, so, if you go into the literature and see, you will find out that various models have been proposed over a period of time, which some of them have been incorporated into the products as well, and some models are still have a theoretical basis. So the first model which I will discuss over here is the Clifford model, which obviously uh, introduced by Clifford in 82, and you can see the reference on this slide as well. So the Clifford first time introduced the concept of historical database model. So his model is named as HDBM, historical database model. Uh, what he did is that he developed a formal theory of database semantics with time and calculus-based query language. As we know that whenever we talked about query languages, two there are two ways by which we can develop those languages. Either we can go for algebra, or either we go for calculus. And what is the difference between these two? That whenever we have an algebraic query language, it means that we are based on operators. We are based on operators. And when we talk about calculus based, it means that there we have the predicates, and we use those predicates or conditions to represent those queries. So his model is basically based on the calculus-based query language, which he proposed in 83. You can see the reference, that is CW83. Uh, what is the importance of this model? That in this model, he introduced the concept of uh, state into the table. The tuples of the relation are time-stamped with the help of special attribute namestate. So what he did is that he used the time-stamping approach, and he managed that time-stamping with respect to state. And furthermore, apart from the state, he also introduced the concept of another, you can say, a sort of an attribute that is called exist, which is a Boolean valued attribute, which basically indicates within the relation that whether that particular record or a tuple exists or not at a given point in time, at a given particular state, which he referred uh, in his model. So in the Clifford model, the output of the relation will be like this. For example, here we have the attribute. Let's suppose we have an employee relation, and we want to represent that employee relation in terms of the Clifford model. So here we have states. Let's suppose Ali is a subject we're talking about, is an employee, and that Ali has, for example, various instances. He may be a part of various departments, and he may have various managers as well, and his salary is also is a variable factor over a period of time. So what he did is that he augment every tuple with a state. For example, in the first instance, you can see the first diagram, that is 2A. If you see that all these values are being represented as state 1. So you can say that at the given state S1, the barber do exist, and the manager himself is barber and belongs to a finance department, and his salary was 12K. And whenever we update that relation, so according to the Clifford, that we always have a new relation with new states. For example, you can see in the second relation, that is S2, here you can see that he represented the facts with the state 2. So every time, whenever talk about the basic concept of the state is that whenever there is a change in a given relation. So whenever there is a change in the given relation, so we have various states. What is the why he introduced these concepts? You may ask this question because remember that he want to introduce the historical database model. So in the historical database model, he wants to maintain the history of the records that were there in the database. So in this scenario, what he tried to do is he tried to manage all those relations in terms of the states, and also you can see another attribute that exists, whether it exists or not. You can see that in the second state, you can see Ali is not, does not exist. And you can see that there is a null value in the manager, there is a null value in the department, there is a null value in the salary. Maybe Ali was there in the state one, but now Ali is not there. So you can see the values have been changed, has been changed. You can see in the first relation and in the second relation. So in the same manner, he manage all those temporal relations so that he can switch over to the states. So he can manage the historical data, and by using the calculus based query language, we can determine the values in the past which were there. So that is the basic concept of the Clifford model. So whenever we talk about various models, they have various approaches, and later on we will discuss which approach is best suits now, and how we can use this. So the next model, which is also relevant when we talk about the temporal databases, is the Arrive model. Arrive also proposed a model, and that model is termed as temporally oriented data model, that is proposed by Arrive, and that was proposed in 1986. You can see the reference, and I also want you people to go and find out that reference and read those models carefully, because in this presentation I just want to give you the importance, or you can say the main construct of the model, but it is always I always want you people to go and study in detail that how that model works actually, so that you have the understanding what people have tried to do in the past. And when we study these various models and approaches, then we understand that how that concept arrived in the last 2, 3 or decades. And of course, when we study these models, we will be able to understand that what is the better approach. So we might think about new interventions, we might think about new approaches, and we might think about some new operators which may work well when we design our models. And therefore, it is important to understand. So this is called temporally oriented data model. He named in this way, and it is based on the concept of data cube. So he introduced a new concept, which is totally different from the concept which was proposed by the Clifford, and that concept is data cube, comprising of 3 dimensions. So he gave the concept of a cube where, according to Arrive, there are 3 important things which we have to consider, and he take them as a cube, data cube. And according to him, the things which are part of this data cubes are attributes, the tuples, and the time. So of course, the attributes are relevant, and of course, the combination of the attributes forms the tuples, which are your records, your facts, and the facts normally changes. And of course, the third important thing is the concept of time related to those tuples. So supports an explicit and inherent order of the tuples contained in it. So the other important thing is that it supports basically an explicit and inherent order. What does it mean? when I say an explicit, it means those conditions are being represented. You can see yourself in the model that those are defined explicitly. When I say implicitly, it means the structure is within that model, which you cannot see, but it is represent implicitly. So here we're talking about explicit nature, because even in the previous model also, the Clifford model represents in an explicit manner. When I say inherent order, it means of course, when we define those tuples, we can understand by the tuples itself that how they are being defined, because the inherent order is there. We can easily understood that whether those tuples are representing the facts right now, whether those tuples are representing the facts which were in the past or maybe in the future. The Q preserves the identity of the tuples and the temporal context of the data. Uh, how that cube will be represented? That cube preserve the identity of the tuple. So every identity, what is the identity of the tuple? Means that the fact changes with the passage of time. So once we have that cube which is defined, it means the identity of the tuples are is being recorded. Means you can refer to any tuple which is there in the context of attribute, tuple, and time, and temporal context of the data as well. So whenever we introduce the concept of time, so it means that we have the temporal context, that we should know that what time we are referring to. Arrive model is a bitemporal relational model. As we have discussed earlier on, that there are various kind of temporal models. In the class we have discussed, and during our online lectures we have also discussed that there are various approaches of temporal models, which includes the rollback databases or the historical databases, and there we have also discussed the concept of bitemporal. Whenever we say a bitemporal relational model, it means that we are basically incorporating two various dimensions of time. And as you know that there are two basic concepts of time which now can be recognized as the valid time and as well as the transaction time. So at that time, Arrive introduced the concept of bitemporal, and he introduced that concept into the relations. One other way by which we can recognize the relation of temporal models is the concept of whether they support the tuple time stamping approach or they support the attribute time stamping approach that we have also we have also discussed in our classes, that whenever we say a tuple time stamping model, it means that the time is coupled with the records. And whenever we say attribute time stamping model or attribute time stamping approach, it means the time is coupled with attributes. That is the difference between the tuple time stamping approach and the attribute time stamping approach. Whenever somebody proposes a model, they always define it in terms of that whether they support the tuple time stamping or whether they support the attribute time stamping. Both have their advantages and disadvantages. Most of the models which were proposed, if they are based on the relational model, they prefer tuple time stamping approach. Why they prefer tuple time stamping approach? Because in the relational model, we have the concept of atomicity. So we try to keep that concept, and we do not want to change the concept or amend the concept. And we allow, in this way, we allow to record various tuples. Otherwise, if we coupled attributes with the time, the problem is that it means that we are allowing multiple values at the same point in time, or at that particular instance. And as you know, that the classical relational model does not allow us to have multiple values. So it means that the normal form which normally we apply in the classical relational models, we cannot apply over here. So it supports the tuple timestamping. The tuple timestamping approach is easier approach to handle with relational databases, in terms of the you can say the application of a language or a query language. So it suppose the tuple time consider both valid time and as well as the transaction time. That is why it is called bitemporal. So he introduced both the concept. The validity of the data, it means whether the fact is true at the given point in time is the validity of the table of the data. And whenever we say a transaction time, it means when that data is being recorded. So we have discussed these two dimensions previously as well, and what are the relationship between valid and transaction time. And of course, because it supports the tuple timestamping approach, and it uses the relational model approach, so it is based on first normal form assumption. So all those models which are based on tuple timestamping approaches and targeting the relational database model, it means they are developed in a way to support the first normal form assumption. And what is the first normal form assumption? The first normal form assumption is that there are no multiple values at particular in point at any row column position in the given table. So at any if you want to see any attribute value in that particular relation, it gives only one value, not the list of the values. That is why it is called that it obeys the first normal form assumption. And you can see the table over here, that is an example relation of the arrived model. For example, we are talking about an various employees and their association with various departments and their position. So their position might changes over a period of time. Whenever employee works in any organization, the employee gets promoted and they have various positions. So let's suppose they want to keep that data in the arrived model. So in the arrived model, he introduced the concept of valid time and transaction time. One more thing which is important in terms of the models whenever we study is whether the model supports the interval based modeling, or the model propose the point based model. So in this model, the values which are being represented in the valid time and the transaction time is basically represents the time point model approach, because here we are not using the intervals. Handling time points is easier as compared to the intervals, because whenever we go for interval based operations, it requires the introduction of various new operators, and obviously the support of those operators were limited at that time. So they come out with this model which is based on tuple timestamping, which is a bitemporal approach, means both transaction time and valid time, and based on the first normal form assumption. And this arrive model is based on the time point approach. And you can see, for example, in the second record, that the valid time is March 2003 and the transaction time is Feb 2003. So that this is possible. Valid time, if you compare those valid time and transaction time may be less than the valid time, transaction time may be equal to the valid time. As you can see in the first record, that both points which were given in that particular table are same. So it might be possible. And it is also possible that the transaction time is greater than the valid time. So all these possibilities can be represented in this table in the arrive model. The third model, which is here, which I want to discuss briefly, that is called the Ghadias model. Ghadias model is basically called the homogeneous relational model. When I say homogeneous relation model, sometime it comes in our mind that there may be heterogeneous relation model. Yes, it is quite possible, but that is the name of the model which was proposed by Ghadias based on his assumptions, which will be discussed in this slide. So that model is always represented as HRM, and it was proposed by Gadia in 88. And again, you can see the reference and you can go and find out what he actually did with all examples and explanations. So here we just want to introduce you some of the important highlights of Gadia's model. So Gadia's model is based on interval time stamping. So introduce a new concept, that is the concept of interval time stepping. So he, in this model, the Gadia used the interval approach. As I discussed previously, that whenever the models are proposed, some you can categorize them as point-based models or interval-based models. So, so the Gadia's model is basically an interval time stamping and supports only the valid dimension. It does not support the transaction time. So according to Gadia, we can represent relation by using interval time stamping, and we can support it only support the valid time dimension. He proposed a new concept, and that concept is now known as homogeneity assumption in any database. What does it mean? A temporally homogeneous database is a database which is restricted to having temporal relation in which the lifespan of all attribute values in other relation in which the is same. Okay, it means that it is restricted to temporal in which the lifespan of all attribute values are same. Okay, what is lifespan? I think we have, okay, you can see over here. The lifespan of a database object is the time over which it is defined. That is called lifespan. For example, we talk about a particular entity. Let's suppose a particular item. That item is being recorded, and it has. Let's suppose it is that item is available in the mart. So for how long that item remains in the mart, that represents the lifespan. For example, we talk about an employee. So employee works in the organization. So for how long that employee works in the organization, it is the total lifespan. The valid time lifespan of a database object refers to the time when the corresponding object exists in the model reality. So when we talk about the valid time, always represent when the fact is true in the given reality. So when we talk about valid time lifespan, it means that when the corresponding object exists in the model reality. As I give you some example, for example, an employee joins the organization in a particular designation, or receiving a particular salary or a grade, but over a period of time, his responsibilities are changing, and maybe his scales and salary is also changing. But how long that particular employee is being valid in a particular organization? So let's suppose he works there for 7 years. So that is the valid time span of particular object. Maybe he left. So might be he left. We have that data with ourselves because we do not discard that data. That data is available, but it means that the validity of the data remains within the given lifespans. And in a given lifespan, various, when the object is true, means various designations, means various salaries. So we have the concept of lifespan now, and we call it the valid time lifespan. And when we talk about transaction time lifespan, it means it refers to the time when the database object is current in the database. So transaction time lifespan refers to time, means that whether when the fact is being recorded, and that is important for us. So it means that how long we perform transactions on that particular records. So it is not necessary that whenever we have a valid time lifespan, that there is the same transaction time lifespan. So it is quite possible that the validity starts after the transaction time lifespan, or the validity starts maybe before the transaction time lifespan. So that is the concept of lifespan. Now coming and when we talk about homogeneity, homogeneity is means that whenever the lifespan of all attribute value within it are identical, so the lifespan of attributes will remain the same. We cannot change the lifespan values for various attributes, so it will remain the same. So what will happen? The handling become easier, because if we have various lifespans, then it will be difficult to manage those lifespans. So he introduced the concept of homogeneity rather than heterogeneity. Homogeneity is also specific to some time dimension, as in temporally homogeneous in the valid time dimension, or temporally homogeneous in the transaction time dimension. So homogeneity always refers with respect to time. Going back to the Ghadias model, so he introduced the concept of homogeneity, and we have discussed the concept of lifespan. Now he introduced another concept in his model, and that concept is that concept of temporal element, which is what? Which is a finite union of intervals. So he also introduced the concept of temporal element. Why he introduced the concept of temporal elements? Because here we are dealing with intervals. So if some fact is true in one interval and some fact is true in another interval, then we can define a temporal element such that we can take the union of these two intervals. Let's suppose a fact is true from 1 to 3, and let's suppose the fact is true is from 3 to 5. So if we combine these two intervals together, it will be from 1 to 5. So it means that what you did is you take the union. So here I talked about the continuity of the intervals. You might have discrete intervals as well, not necessarily continuous. For example, a fact is true from 1 to 3, a fact may be true then from 5 to 7, and then from 7 to 9. So if the fact is true in three various intervals, an element can manage all those intervals in terms of union operations, which what union does, as you know, union, whenever you apply a union operator, it means that you are combining all those intervals together. Temporal version of relation algebra using snapshot semantics was also in this model. He also introduced the concept of snapshot. What is snapshot? That is important. Two things which are important over here. One is that he introduced the concept of temporal version of relation algebra. As I discussed earlier on, that there are two ways by which we can manipulate that information. Either you can go for relational algebraic operations, or you go for calculus based operations, not operations, sorry, calculus using calculus related predicates. So here he used the concept of relational algebra, and he used the concept of snapshot semantics. Snapshot, what is the concept of a snapshot? Whenever we talk about a temporal database, uh, either you record the objects in a continuous manner, or you record the concept in a discrete manner. So if you want to record the concept in a discrete manner separately, let's suppose a fact is true in this interval, then the fact is true in this interval, and then this interval, it means, or even on at a particular point in time, then we call it a snapshot. For example, let's suppose whatever the states which are being represented in a particular database in a given time is called as a snapshot. So let's suppose if I have a snapshot at t0, that is the one representation. That then I have another snapshot at t1 that represents another representation of that particular data, then t2 and then t3, because all these models follow the linear structure. And whenever we talk about the linear structure or a linear discrete structure, it means that we follow the order t comma less than. It means that t naught is greater than t1 is greater than t naught, t2 is greater than t1. So t1 is less than t2 and greater than t naught. So let's suppose we have three various snapshots available at t naught. And right now, whenever I say t naught, t1 and t2, it means I'm talking about points. And let's suppose in this particular model, the intervals are being used. So it can be intervals maybe. For example, we have 1 comma 2, we have 3 comma 4, we have 2 comma 4, we have 3 comma 5. So these are various intervals. So we want to keep that snapshots available on various intervals. So that is the representation of the Ghadias model, and you can see the representation of the relation in the Ghadias model. Here you can see that the name Ali, his salary and department, you can see. If you want to see what is homogeneous, just see the intervals over here. Same interval is used 9,41, same comma is used for, same interval is used for department. Same interval 41, comma 52, and same interval is used here. That is called homogeneity. If, let's suppose, these relations are being managed at various intervals, then it means it is not homogeneous. Then it means it is heterogeneous. So in Gadia's model, the important thing is that he introduced the concept of homogeneity, because you people know that handling homogeneity is much easier as compared to the heterogeneous approach. And on the left hand side, you can see the operations which take the union. For example, the fact is true from 018 to 1846. So you can see on the left, the interval is defined, and you can see the brackets. I think you have that understanding that represent the closed interval and open intervals and so on and so forth. So here you can see on the left hand side that it takes the union, which defines the temporal element, as we discussed in the discussion. So in this way, the Gadia represented the his model, which is called as HRM, Homogeneous Relation Model, Homogeneous Relation Model. So here, that is another model which we will discuss over here. That is called Benzavi model. Benzavi model, which is introduced by Benzavi. All those models are introduced by various researchers. So all those models are normally represented by their names. So Benzavi's model is also an interval tuple-based time-stamping model, which represent the tables in terms of tuple-based time stamping and also use the interval modeling approach. This model introduced various times. So he came out with a concept of various times rather than the concept of valid time and transaction time. He introduced the concept of effective time, registration time, deletion time. Somehow later on, people have represented his approach in terms of valid and transaction time. So you can find out the analogy which may exist with his various time attributes and with the conventional time attributes which we have discussed. And you can see in this relation,
where we have various attributes from A1 to AN, and then we have the transaction effective time, the effective end time, the registration start time, the registration end time, the deletion indicate the time when the information in the tuple was logically deleted. So we always go for updates. So whenever we go for updates, we delete the information. Sometimes we delete the information. So it also kept the deleted information as well in the table. You can see the representation of Benzavi model over here, and you can see that we have employees, we have departments, and now you can see that there is a start transaction time, end transaction time, start effective time, start end effective time, and then we have the deletion time. Let's suppose you can see the second tuple. Here you can see it is being deleted in January 2002, so on and so forth. Intervals are being managed in two different ways. You can see in the previous model, Gadias model, here the interval is managed in terms of, like you can see yourself, of representation of time. For example, 9,41. So it is represented, the interval is represented inherently into the model. But here in this model, however, he used the interval based approach, but what he did is he used separate attributes, not the interval as it is. He used the separate attribute, the start time and the end time. So once you have the start time and the end times, you naturally you will have the interval. So in that manner, the Benzavi managed his relation. And although there are a lot of discussion, because handling so many attributes in a relation is always difficult, it increases the you can say the volume of the data, and it is sometimes difficult to manage all various time attributes. And of course, whenever you apply various operators, it is not give you an optimal way to get your queries as well. So there are always we have the advantages and disadvantages, pros and cons of various modeling approach which we are discussing. So here I will stop, and that is the first part of this presentation which I will share with you. Thank you.